Hello and welcome to this talk about the future. I'm Stuart Armstrong from the Future of Humanity Institute, part of the Oxford Martin School in the University of Oxford. So we're going to be looking at the future and try to answer the all-important question, is this the kind of place where we'd like to live, given that we have to live there? The plan for the talk is as follows. I'm going to start by inflicting some very light future shock on you. Don't worry, that's not nearly as painful as it sounds. Then we'll have a look at the epistemology of prediction. That's just a fancy way of saying we'll look at what we can predict, what we can't predict, and how we should interpret the predictions of others. We'll have a brief look at what could go very wrong, and a brief look at what could go very right. And we'll conclude by looking at the ethical challenges and issues. First, as promised, future shock. We all have a tendency to underestimate how weird and different the future could be. We underestimate the impact of small changes, small transformations. So to sort of broaden our horizons a bit, our mental horizons, I'm going to have a look at some minor changes that would have huge impacts. The first one is, what if lie detectors actually worked? What if some scientist announced tomorrow that due to their brain scanning capacities, they now had an effective lie detector, it actually worked and there was no doubt about this? How much would society change? Well, for a start, the court would be quite different. It would be reduced to, did you commit that crime, followed by acceptance or denial, and it would all be over in about 30 seconds. If you think of sort of the centuries of legal traditions that would get overturned by just a simple thing as a lie detector, this gives you a small idea of what future shock could be. But the court is a very minor thing. What about job interviews? Same thing. They could be over in 30 seconds for some positions. This is all still a bit impersonal. Social relations might change. I hope that tomorrow's relationships won't be over in 30 seconds, though. But again, maybe we should be thinking bigger. What about politics? Is this going to be enough for tomorrow's politics? Find the politicians whose views you agree with and check that he honestly has them. What about an even larger scale? What about international relations? There are a lot of treaties that we don't do nowadays because they're just unenforceable. We can't check that the other side is falling in line with them. Here it would be easy to check. You can check ahead of time whether they intend to obey the treaty, and you can check after the fact whether they are actually implementing it. And of course the important bit is that it's mutual. So you can get trust forming between nations, even if they hate each other. They can trust that they will go along with their obligations. Okay, this is some of the consequences of lie detection. What other things might have a very large impact? Well, let's consider artificial intelligence. And by artificial intelligence, I mean a software entity with human-level skills. Not going to get into a debate as to whether it's conscious or not, just that it has human-level skills. At the moment, we don't know how likely it is possible, but I'd like you to just think now of your own sort of probability estimate. How likely do you think that something like AI will happen in the next 100 years? You got that number? Right, now let's have a look at the consequences of AI. The first and easiest one is total unemployment. You would have one AI, you could make copies, train a few of them in certain skills, and then once they're fully trained, copy, and replace every position in every office that you'd ever want. Of course, there'd be no need for an office after that. What other things could AI enable? Well, total surveillance, for instance. You could create a drone with an AI in it, and a being with the same intelligence as the human mind, and it could follow any one given individual around. You could build a lot of them. Why not 8 billion? One surveillance drone for each person on Earth, with a smart being individually tracking every single one of your gestures. And we could build this kind of infrastructure with AI, because AI will permit extreme improvements in manufacturing and economic growth. If robots have truly human skills, they'll be capable of building, well, not necessarily building more robots, but building the infrastructure that allows for the building of more robots, building the factories that allows the creation of more robots, and then produce pretty much anything that our resources on the planet or allow. Well, maybe total unemployment, total surveillance, and extreme economic growth is not enough of a change. Let's think a bit bigger. In a paper that I did with Anders Sandberg, which analyzed the Fermi paradox, we looked at how difficult it would be to, say, build solar captors all around the sun, a Dyson swarm, basically. And with automation, with true AI, it's surprisingly easy. If you started on, say, Mercury, you could go through a cycle of getting energy, using the energy to mine materials, putting the materials in orbit, manufacturing that into solar collectors, which then allows you to get more energy and beam that back to Mercury and continue the cycle. At each stage, you're building more factories, which you can, run by AIs, which are smart, and they're overseeing every stage of the process. Under some relatively mild assumptions, if we had AI, we could get this amount of energy as we build more and more captors over a period of about 30 years. Now the graph has stopped at about 30 years. And why is that? Well, that's when we ran out of mercury. And interestingly enough, the actual details or the assumptions are not all that important. As long as we have the exponential feedback loop at the beginning, which we would have with the ability to copy AIs, then we can disassemble mercury in reasonable amounts of time. Okay, but maybe this is still a bit small scale. 1 star? How about the entire universe? In subsequent calculations in our paper, we showed that with this energy from 1 Dyson swarm around the sun, you could power a mass exploration fleet to self-replicating exploration fleet with AIs on it to colonize every single galaxy in the universe that we could ever reach. And all these are the consequences of having AI. But here there's an important point, is that we should not judge the probability of things by the strangeness of their consequences. Our paper demonstrates that there's a reasonably high probability of universal colonization given AI. However, this does not affect at all the probability of AI. Nada. No impact whatsoever. Remember, I asked you to think of your probability of AI before? The number should be still exactly the same as it was before. Just because something has weird consequences does not make it less likely. Okay, that's a bit of future shock. Now time for some reverse future shock. There are some things that actually in our culture we expect to have huge impact, even if they're probably going to be quite minor. The example that I'm going to use here is biological immortality. If we just get rid of death, This is a Woody Allen quote. I don't want to achieve immortality through my work. I want to achieve immortality through not dying. I don't want to live on in the hearts of my countrymen. I want to live on in my apartment. So what would happen if Woody Allen actually got his wish? Well, the first thing that people always bring up is population growth. Wouldn't the population growth be quite extreme? That's not all that hard to deal with. Say we did a worldwide one-child policy. Maybe this would be the quid pro quo. You can become immortal if you promise that every couple that you're in will only have one child. If we start with a population of 8 billion, what would be the consequences of a worldwide one-child policy? Well, all the current generation would have up to 4 billion children. Those 4 billion children would have 2 billion children. Those 2 billion children would have 1 billion children. And so on. The world population would never go above 16 billion, simply with a one-child policy and immortality. So, and this was just a solution that took a few seconds to think up. Population growth will not be a problem. People worry about pensions and things like that. Now, of course, we're assuming healthy immortality. So pensions paying for pensions would not be a problem, because now you would have a huge workforce. You'd have to sort of change a bit what people's expectations in life would be. You couldn't sort of work for a certain amount of time and then retire. You'd have to sort of work continuously and have time off continuously and get a better balance. But this doesn't sound like a huge challenge. Family life would get changed, yes. If great-grandpa is around and commenting on the sinfulness of the youth of today, there might be a difference in relations. But family life in the West especially has already changed quite a lot, and we're down to sort of small family blocks that eventually push out children into the big wild world. So it doesn't take much to adapt to actual immortality. And philosophical and religious adjustments. Now, some people think these will be huge. I don't think they will be. If you go back and see how religion has changed over the last centuries, while generally claiming not to change, but you go back to Catholic beliefs in the year 1000 and today, there's absolutely no comparison between them. So philosophies and religion will adjust quite easily, I think, to this new kind of world. This is, for instance, a late 19th century French family. Considering what the people of these families would have gone through in the 20th century, considering the social, economic, health, and technological change that they would have lived through, and compared with today, the difference between them and us is much bigger than the difference between us and immortal versions of us. But what is this future that I keep on bringing up? How can we ever predict anything at all? Well, there's some things we're pretty good at predicting. These are variants of Moore's law, and they've been going for quite some time, and they seem pretty solid. People have predicted using them, and they've been correct. There's various economic and technological trends that can similarly be predicted, and you won't go far wrong by extrapolating them. But sometimes our predictions get very wrong. Here's just a small sampling from one of the best medics of his period, economist, an expert in cultural a Decca Record executive, and Fukuyama's famous prediction of the end of history. Now, all these people were kind of at the top of their profession. They had a lot of experience, and there was a lot of reasons to take them seriously when they said these kind of things, and they were all very, very wrong. And at this point, we should guard against hindsight bias. This cartoon says, "It was so obvious that this Bali bombing was going to happen. I can't believe the government didn't foresee it. Just can't believe it. Where do you think the next one might be? The next one won't be so predictable. That's obvious. Anyone can see that." So the examples I gave previously, it's fun to sneer at them, but at the time, we wouldn't have been able to do better. Or if we had been able to do better, it would just have been by luck. There is no reason to think that our predictions today, no matter how solid they feel, are not just as wrong as the previous predictions. Now, this is a XKCD cartoon which has fields arranged by degree of purity, where everybody gets to sneer on the least pure discipline. To quite a good extent, it's also the fields arranged by predictability, from least predictable to most predictable. Generally, when a physicist tells you something, or tells you something that they expect to see as the result of an experiment, they're probably going to be right. When a sociologist says the same thing, could go either way. But why is it that some fields are so much better at prediction than others? Well, it's mainly because, here's economists and historians on the graph, incidentally. It's mainly because they have access to different kinds of methods. Mathematicians are proud to be able to use deductive logic, whereas physicists and chemists have some pretty strong versions of the scientific methods, weakening down to sociologists who have very weak versions of it, and poor historians who are reduced to talking about past examples. Now, where should we put most future predictions? Well, most of them lie in this convenient empty slot down on the left. And the reason that most future predictions are so inaccurate is because all they have to rely on is expert opinion, which is considerably less reliable than everything else here. And incidentally, one thing that you might think that as you go down here and as the predictions become less certain, that maybe the experts take them with a grain of salt, become less dogmatic about their beliefs, are more willing to entertain opposing ideas. No. Let's just have a brief look at one example from economists. Here we have Paul Krugman saying very nice things about Chicago School economics. Here we have a Chicago School economist responding in a similarly generous spirit. Now, economists, we should realize at this point, is a discipline where GDP predictions are generally adjusted by 1.7 points. Those numbers that are reported that the economy grew 2% or shrunk 1% this quarter, generally afterwards they're adjusted, and the average adjustment is about 1.7 points, which is more than enough to swing a recession into a growth or vice versa. So when you're in a discipline with this quality of data, how can they get so dogmatic about their certainties? And it's really annoying because both of these people have real, genuine expertise buried inside them. They've studied these for a long time, they've developed a lot of techniques and wisdom, And we would really want to be able to reach in their minds and take advantage of their wisdom. But while they are opposing each other like that, we can't, unfortunately. This is sort of the picture-proof, cartoon picture of disagreements. In our disagreements, in our minds, we have a variety of things that cause us to believe what we want to believe. Things like life experience, evidence, thought experiments, detailed arguments, and, let's be honest, some biases and rationalizations. All these lead to reasonable seeming conclusions. What about the people that disagree with us? It's exactly the same situation. They go through exactly the same mental process as we did. Except from within our mind, all we can see is this. What this means is that no matter how right we feel, no matter how much all our feelings and intuitions are telling us that we're right and our opponent is wrong, we have to disregard this. We cannot ignore the opinions of people that disagree with us unless we have an objective reason to assume that we know more than them. Genuine expertise, a measure of genuine expertise, and of course, a proper one, not just everyone claiming their own objectivity criteria. Fortunately, there has been some research as to when experts are genuinely skilled and when they're not. This table, which I reproduced from James Chanto's paper, shows when we expect good performance and when we expect poor performance. It generally depends on the task the expert is trying to do rather than on any other feature of the expert. And tasks that have things that are on the left will have good expert performance. Tasks that have features on the right will have poor expert performance. Now, these lines are not all equal. In my opinion, these three are the most important. Again, agreement versus disagreement, whether the problem's decomposable or not, and towering above everything else, whether the experts get immediate feedback or not as to their predictions. Now, I'm going to have a look at AI or AGI. So, what experts predict about AI. And if we look at that, AI predictions have these features, and it's pretty much stuck with that until such time as we get an actual AI to analyze. So just before doing anything, before looking at anything, we can predict that we expect that AI timeline predictions are going to be very poor. Okay? That's the theory. What's the practice? These are a systematic search for expert and non-expert timeline to AI predictions. And we got those and we plotted them for the date the prediction was made. This, incidentally, is Turing's original prediction for the Turing test, and in the middle here we have the AI winter, where no one was doing or talking about AI at all. First thing to note is the predictions are all over the place. The difference between any two lines is 20 years, and so the standard deviation of these predictions is huge. There's no evidence that experts are honing in on some shared wisdom. And there's no evidence that experts and non-experts have any difference in performance. A strong tendency, incidentally, is for people to predict that AI will happen within 15 to 25 years of whatever date it is now. So, why is predicting AI so hard? Well, it is a confusing problem. This is a Kurzweil cartoon, and it basically shows the human race desperately writing a list of things that only humans can do. And since this cartoon was published, more and more of these things are falling off the wall and going into the pile of things, yes, computers can do it as well. So it is becoming harder and harder to identify a uniquely human skill, something that humans can do and computers can't. There still are a few, but we can't be sure that they might not slide off the wall in a very near future. On the other hand, despite all these achievements, there is no real evidence that we are achieving anything like some sort of true general intelligence. For instance, this is Watson, who recently triumphed on Jeopardy. Jeopardy questions tend to be sort of, well, anagrams, parables, riddles, and Watson beat the best human players around, such demonstrating certain types of linguistic ability that no computer had ever showed before. Now, this was very impressive, and if you'd gone back 50 years and told people, we have a machine that can win on Jeopardy, they would have concluded, okay, it's done, you have a general AI. But we don't. You can tell this even from some of Watson's answers. This was Watson's answer to its largest airport was named for a World War II hero, its second largest for a World War II battle, and its guess was Toronto. Now, you might say this is not a bad guess, but the category was US cities. Watson makes the kind of stupid mistakes that any reasonable human would not make. Watson is not a general intelligence. So these are the two trends that make predicting the arrival of general intelligence so hard. The fact that we can't isolate something that humans are certain that they can do, and that computers can't, versus the fact that these things keep on falling to computer abilities without there being any sign of general intelligence. Anyway, that's enough looking at predictions for now. So just bear in mind, predictions are very hard. Expert advice, expert opinion in many of these fields is worthless. And you can analyze the field that the experts are in to see whether it has the right features for you to expect good expert opinion. And lastly, disagreements are really an important barrier. If someone disagrees with you, you have to have strong objective evidence to be able to reject their opinion. Well, let's look at the future again. Instead of trying to predict, let's say, well, what's a worst case scenario? We should focus on the big scale risks. Small scale things going badly is not really all that interesting. In this Dilbert strip, it's shown that Dilbert does indeed know what worst means. This is a variety of risks and dangers put on a graph based on their intensity and their scale. So a fatal car crash is a terminal intensity, but it's only on a personal scale. The loss of one species of beetles, this is forever, but it is a very small intensity. Of larger intensity and scale are global catastrophic risks, such as dramatic loss of biodiversity, the destruction of the ozone layer, aging potentially. And in the final box, and the maximum scale and maximum intensity, comes existential risks, the really bad stuff. So what are really bad stuff? Well, we can try and look at history and see what really bad stuff we've had. These are an approximate list of past events that have killed over 10 million people. So what these are the sort of the global catastrophic risks of the past. So what are the big killers? Well, war is definitely up there. Bad governments have their share of the blame, especially the big totalitarianisms. Bad government, and also to some extent lack of governments. Period of anarchy are also extraordinarily deadly. So lack of good governance is probably the key thing there. But much more important than either of these features is diseases. Pandemics have been by far the biggest killers in human history. And this, incidentally, explains why the World Health Organization always overreacts to every pandemic. This is the UK Chief Medical Officer on the 2009 swine flu. Worst case scenario, 65,000 killed. What actually happened? 392 people were killed. Why was the prediction and the outcome so out of whack? Well, it's because epidemics or pandemics follow what's called a power law, and they follow a rather sharp one. What this means is that the deadliness of pandemics is heavily concentrated in the very large ones. The average pandemics have few deaths, but the average deaths per pandemic is absolutely huge. This is, for instance, an illustrative, not exact numbers of processes that obey these kind of power laws. That the worst event is responsible for about 80% of the deaths, the second one has 15%, and all the other ones are tiny in comparison. What does this mean? Well, this means that you should always overreact to any pandemic because of the tiny probability that it goes to the extreme end of the scale. Okay, so pandemics are just one example of existential risks. What are the others? Well, the ones that we study at the Future of Humanity Institute, in no particular order, are pandemics, synthetic biology, nanotechnology. We may be dropping that from the list soon. Artificial intelligence, and an oldie but a goodie, nuclear war. Two that we're not studying are asteroid impact and environmental collapse, just because in relative terms they're not risky enough. Now, I'll have a bit more look at artificial intelligence later, but here's a brief aside, a 2-second pitch as to why synthetic biology is bad. Because synthetic biologies are potential pandemics, which are already bad enough, plus human direction. Right, let's have a look at AI. Now, some people feel that clunking robots are the AI risk. It's nothing like that at all. The real AI risk comes from intelligence. This on the left is a chimp brain. Chimps have a population of about 200,000 and use basic wooden tools. Human brain, we've spread across the entire planet, have heavy industry and nuclear weapons. The small difference in our brain size explains this. Ever since we've added computers to our own intelligence, we've landed on the moon, developed hydrogen bombs, and had unprecedented economic growth. if these relatively small increases of intelligence can cause such a huge change in outcome, what would the next step on the ladder do? Okay, that's enough cheerful doom and gloom. Let's have a look at some things that are not problems, but are often brought up as problems. Overall lack of water, food, and energy is one. Now, distribution of these resources is a problem. Future transition costs are a problem. But the overall lack are not a problem today and are not going to be a problem in the future. Why? Well, let's have a look at water. We could replace all our water usage, agricultural, drinking water, all of it, with desalinated water at the cost of about $2 trillion a year. We could eat only hydroponic food. Here the estimates are a bit more uncertain, but it would be between 0.6 and $5.4 trillion a year. More likely on the low end of that scale. Solar energy, we could get 16 terawatts of power at $7 trillion a year. And a total slightly under $14.4 trillion a year. At current prices, assuming no efficiency gains whatsoever. How much do we spend on water, food, and energy today? About $10 trillion a year. So, at costs very comparable to what we're spending now, especially if we factor in efficiency gains, we could drink desalinated water, eat hydroponic food, and get all our energy from the sun. So as I said, huge distribution issues, but overall lack of these things, not going to be a problem. That was the indifferent stuff. Let's have a look at the good stuff. There are some problems out there that could be solved, actually got rid of. Dustbin of history, like smallpox. What kind of problems could we solve? Absolute poverty, for instance. We've made progress on this. With more technology and some better social institutions, we could get rid of absolute poverty. Blue-collar crime. Things like mass surveillance, for instance, or even just everybody having an iPhone, could completely deter violent crime. I say blue-collar because it's the one that's easy to see that it's a crime when you look at it. War. It's another problem we could solve. Violence in general. Mental illness. With all the future resources, the analysis resources, the tracking resources, we could make great strides into finally getting rid of mental illness problems. Disease in general. There's no reason we have to live with disease. It's not our destiny. Death. Same thing. Why stick around with death if you don't have to? Okay. What about great stuff? Well, here we're getting into slightly more contentious territory. How much better could things get? How much room for improvement is there in the human condition? Now, so if we're currently stars, could we have supernovas of happiness, of meaning? Could we make our lives much, much, much better than what we currently enjoy? It may be possible, it may not be possible. I'll just read you a short extract of Nick Bostrom's letter from Utopia, just to give a feel for the potentials that might be out there. This is written back from the point of view of an inhabitant of Utopia. Have you ever known a moment of bliss? On the rapids of inspiration, maybe, where your hands were guided by a greater force to trace the shapes of truth and beauty. Or perhaps you found such a moment in the ecstasy of love. or in a glorious success achieved with good friends, or in splendid conversation on a vine-overhung terrace one star-appointed night. Perhaps there was a song or a melody that smuggled itself into your heart, setting it alight with a kaleidoscope of emotion, or during worship. I am summoning this memory of your best experience. To what end? In the hope of kindling in you a desire to share my happiness. And yet, what you had in your best moment is not close to what I have now. A beckoning scintilla at most. If the distance between base and apex for you is 8 kilometers, then to ascend my dwellings requires 1,000,000 light-year ascent. The altitude is outside moon and planets and all the stars your eyes can see. Beyond dream, beyond imagination. My consciousness is wide and deep, my life long. I have read all your authors, and much more. I have experienced life in many forms and from many angles. Jungles and desert, gulcher and palace, hell, heath and suburban creek and city back alley. I have sailed the high seas of culture and swum and dived. Quite some marvelous edifice builds up over 1,000,000 years by the efforts of homunculi, just as humble polyps amass a reef in time. And I've seen the shoals of coloured biography fishes, each one a life story, scintillate under heaving ocean waters. Now this is very allegorical, of course, but it's just to give a flavour of, well, the great positives that might be out there. And if they are out there, if it is true, it'd be quite important to get there, don't you think? And if we're not sure if they're out there, it'd be kind of important to find out. Anyway, we've seen the good stuff, we've seen the bad stuff. What are the big ethical questions for tomorrow? Well, for philosophers, ethical questions is also known as fun. One big ethical question that are looking at the Institute is enhancement. Should you enhance human beings? And there's some strong reasons to suspect this should be completely forbidden. It's sort of artificial, it's silly, and you wouldn't want to enhance students just before a big test, for instance. Or maybe enhancements should be obligatory. Like, if you had a doctor and you had a choice between an enhanced doctor and a non-enhanced doctor before the operation, which would you want? This paper looked at basically the effect of fatigue on surgeons. It's sort of a complicated model. The details are not all that important. The point was that fatigue had definite impacts, definite negative impacts. And when we're talking surgery, this means a statistical increase in death over the large scale. And they looked at Modafinil, and an intervention using Modafinil. And it improved performance on tests of higher cognitive function and suggested that fatigued doctors would benefit from pharmacological enhancements, potentially. If this were the case, wouldn't you want it to be mandatory? Well, or would you? I mean, is this similar to requiring that surgeons wear glasses, which we all agree is an enhancement that we would demand that our surgeon go through? Is it similar to requiring that truck drivers use sleep apnea equipment, or that epileptic drivers take their medication? This whole area is suffused with quite a lot of odd ethical intuitions. Like, Ritalin is a generally controlled substance, but coffee isn't. And both are stimulants, and there's no particular reason why one is controlled and the other isn't. This was a print from 2 centuries ago where this extraordinarily dangerous substance called coffee was all the rage, and coffee houses could get raided and newspapers would thrill at the stories of the debaucheries in there caused by this drug called coffee. So our ethical intuitions about substances seem to be quite poorly calibrated. Let's give another example. Modafinil works also as a memory enhancer. And some people get very upset about this, and there's huge ethical worries. But it doesn't really work as a very good memory enhancement. It has a few percentage increase at most. Using the method of loci, which is a very old method, which involves walking through your memory of a street or a house and putting objects in there to be mentally recuperated at a later date. This memory works much, much better. This memory technique works incomparably better than drug enhancements. And yet, no one is particularly fussed if someone learnt these techniques. If they did this before a test, they'd ace it. And this mental technique is crummy compared with an iPhone. So, yet we're much more worried about the drug than about the technique or the technology. Generally speaking, in fact, tech crushes bio. An illustration of this is the current fastest man alive, and this is a relatively middling sports car. I know who my money would be on at the 100 meters or the 200 meter race. Now, what other ethical problems do we have in the future? Well, how are we going to deal with the likely total shredding of privacy? If we think our privacy has been invaded now, it's nothing compared with what's coming soon. The sort of double plus Facebook that's in our future. What about truth detection? As I got some of the consequences of that mentioned at the very beginning of the talk. How are we going to deal with it? If it arrives, we ban it, regulate it, adjust to it? Total surveillance brings up similar sorts of problems and issues. A simple calculation suggests that by the early 20s, most Western governments will be able to spy on their populations perfectly all the time. By the 2030s, most governments will be able to do so. The last government that will achieve this will probably be Zimbabwe. So this is likely coming, and we're going to have to find a way to deal with it. The reason it's coming is because cameras and storage equipment also follow Moore's laws and are getting cheaper and more effective on exponential curves. Brain reading. This might arrive. We've already seen some evidence for it. This is an experiment where you read dreams or tried to reconstruct. People were watching movies and tried to reconstruct what they saw from the brain activity. The top clip is the actual movie, and the bottom thing is the reconstructed image. Now, as you can see, it's not close, but there are features there you can see with a similarity. And these kinds of methods are probably going to get much better in the future. Now, there are some advantages to total shredding of privacy. The disadvantages are evident, and I encourage you to go and read, for instance, the website blog Boing Boing or Bruce Schneider, who have very good takes on the disadvantages. But there are some advantages. There'd be the reduction in what I call the blue-collar crime, the violent crime that's blatantly crime if you see it. You would have reductions in the necessary size of your police and of your army. If the cameras can catch any crime, you don't need a large police force. You just need a rapid reaction force to swoop down in the few cases where it's necessary. Similarly, if countries can spy on each other all the time, they're much more able to pass treaties and reduce the size of their armed forces. Less corruption. It's hard to keep surveillance totally one-sided, and which means that sort of at least the lower levels of the governments will probably be quite well surveilled, and corruption and abuse on their part will be massively reduced. The chance of the various X risks that I mentioned will be greatly reduced. This is probably the most important factor here. Synthetic biology, you could catch people behaving dangerously. Pandemics, you can track them and intervene effectively. Even AI, that's a bit more dubious. But anyway, most X risks could be quite strongly reduced with massive surveillance. You might get some reduced prejudices. This is somewhat more contentious, but when you get to know and see people of a different culture continuously, it does tend to adjust your prejudices. A sort of minor example might be how the coming out of from the closet of gays and lesbians in recent decades has definitely boosted the their image in the Western world once you got to know them. You can get in better social and medical research. You could kind of do social research instead of getting a group together and trying to make it unbiased and running your experiments on them. You could run it on by looking at the data on the entire population. Similarly for medical interventions. So, will there be near total unemployment in the future? Remember, that's a possible consequence of AI and of even of some theories of increased automations. If that's true, what should we construct? What social system are we going to build to replace our current one, which is so premised on having a job? And when we think as to whether this question is likely, we have another conundrum. We have a sort of inside view versus outside view perspective. The inside view is we just think about our situation and put what we know about it. Now, the arguments for automation killing jobs seem very solid today. I've read a few of them. They are quite convincing and quite solid. It's worrying. On the other hand, the outside view sort of looks at the track record of such predictions. And the arguments for automation and killing jobs have always been very solid. So what to do? What to do with this tension between the fact of the arguments seem convincing, but arguments like this have been repeatedly shown to be wrong. Another future ethical problem is, equality. Who has access to the technology? Do we just let the rich get it? How do we ensure that it's not one person that gets all the upgrades and the other one is left without them? Though, forget about equality for the moment. What about just sort of diversity versus common humanity? If people start upgrading themselves, changing their bodies, changing their minds, and becoming quite different beings, can we talk of one species? Can we keep them together as one species? The beings here, are they the same? Can they relate? Can there be a relationship between, say, normal humans and extremely modified humans? This is a possible conundrum for the midterm future. And the last big ethical problem of today is, should we risk all for the stars? If we spread out amongst the stars, we would have access to vastly more resources than we have today. It dwarfs it on a huge scale. And with that, we could maybe do incomparable amounts of good. Some philosophical systems say that we should try and get the stars, and this would be the prescribed thing to do. But is it worth the risk? So if we had a way of expanding that would get us these trillions of stars, these billions of stars, and it had only one chance in a billion of not killing us all, should we do it? Standard expected utility calculation says, yes, go ahead. If the reward is big enough, we should do it. Now, even if you're like me, you're not convinced that value adds in this way, that with 1 trillion worlds we can get 1 trillion times the value, there still is the question, how much risk should we take for this potentially huge expansion? Anyway, that's been a brief overview of the future and of some of the work that we do at the Future of Humanity Institute. I hope you found it interesting, and I thank you for your time.